Hello grade 12s, welcome to my channel. And if you are a grade 11 student looking onto what you're going into, well, you may consider subscribing onto this channel this early because you will miss out going into the next year. Otherwise, let us have a look at what these guys wrote and have a look at what was necessary to answer these MCQ questions. So we're just going to do the question 1 and see how interesting or how interesting or how interesante it was. Let us have a look and take it down one bit at a time. Question 1. Okay, this is the physical science paper 2, November 2023. All right, let's have a look. We are told here, which one of the following represents a straight chain saturated hydrocarbon? So what does that mean? A straight chain saturated hydrocarbon means an alkane. So the question is saying which one of these is an alkane. So can you see how smart examiners are? They have a way of asking questions in such a way that you may look a bit, delulu or something, but you will be able to find out what's going on in there. Okay, so we're looking for alkanes. So what you call the general formula for alkanes is CnH2n plus 2. So if you follow this one, it says C5H8. So this is already not anything like what we're looking for, because 5 times 2 is 10. 10 minus 2 is 8. And this is basically an alkyne. Now, 5 times 2, that's 10. So this is an alkene. This still is an alkene. And then we look at this one. 6 times 2, that's 12. Plus 2, that's 14. So definitely D is an alkane. So the key here is CnH2n plus 2. Okay. So that is the key to that answer. Okay, so 1.2 says which one of the following is a secondary alcohol? Okay, so if we look at this one, we've got a C and then it's bonded to CH3 times 2. All right, so this one looks very complicated. Actually, it's a tertiary alcohol, because you'll notice that these methyl groups are attached to this carbon. And that means this OH is also attached to this carbon. So when a carbon is bonded to 3 other carbons and carries the OH group, it becomes a tertiary alcohol. Now we look at this one, CH3, CH2, that's part of the main chain. It's not a branch. How do you tell a branch against the main chain? Within the chain, you'll have CH2s multiple times. But if it is a branch, you'll see a CH3. You can never have a CH3 within the chain. Okay, so we'll see that. Okay, essentially this OH is born on the last carbon, or you could call it the first carbon. So this is essentially a primary alcohol. And if we look at this one, once it ends with a CHO, this is an aldehyde. So it's just a dummy there. Then we follow this one and say, okay, CH3, CH2, then there's a CH, but then followed by an OH. This tells us that this OH is attached to this carbon because the last carbon has enough hydrogens on it. So this is definitely a secondary carbon bearing the OH group, and this makes it a secondary alcohol. So 1.2 is also D. So 1.3 says which one of the following is a hydrolysis reaction? So now what do we know about hydrolysis reactions? We know that these are essentially substitution reactions in organic chemistry, as opposed to hydration, which is an addition reaction. All right, so we look here and see this is a haloalkane. We're adding water and then forming an alcohol and hydrobromic acid, or HBr. All right, okay, all right. So what is going on here? We could see that an OH group substituted the halide ion there, and essentially, yes, This is a very slow reaction as opposed to the one we're used to, where we're using a dilute base, which is much faster. This one is slow, and of course we need excess amount of water for that reaction to to go on. But as slow as it is, it ticks the box. This one, we've got CH3CH2OH plus HBr, and here we're essentially forming we are essentially attempting to form a haloalkane. Okay, all right, okay. And essentially we did not add water. We are expunging water. We're squeezing it out essentially. So this is not hydrolysis. Okay, so again here you will see that CH2CH2, it's an alkene, ethene, plus water, and this is essentially an addition reaction. So we don't call this one hydrolysis, we call it hydration actually. Then the last one, we are basically doing hydrogenation. So that means 1.3 is A. Alright, so A is a substitution reaction with water as a reactant essentially. That's the idea here. Okay, 1.4. Let's go on to the next bunch of questions. Okay, in 1.4, we're told here hydrochloric acid reacts with excess zinc. So meaning zinc is not the rate limiting reagent, meaning it will remain after the reaction has stopped. So that means hydrochloric acid is the limiting reagent. That means when it gets used up completely, the reaction stops, even though zinc will still remain at the end of the reaction. So this is one of the reactions we can use to produce a desired salt and mainly to produce hydrogen gas. Now different reaction conditions are shown in the diagram below. The mass of zinc used is the same in both test tubes. Okay, so that means we're using the same mass of zinc. Here we're given zinc powder, and then here we're given zinc lumps. Obviously the reaction rate here is going to be faster because of a greater surface area that is provided by zinc powder than it would be for lumps. Okay, look at the amount of acid used. It's 100 centimeter cubed of this concentration. So that means the number of moles is going to be determined by multiplying that concentration as well as that volume. But for the second scenario, we've got a higher volume of the acid of the same concentration. So this simply means we will have more number of moles in this one than on the other one. So the question says now, how will the initial rate of reaction and final volume of hydrogen gas produced in test tube Y compare with that in test tube X? Obviously in test tube X the reaction rate is faster, so that means the reaction rate in test tube Y should be lower. So our options is going to be B and C. Anything that says higher is already out. But now what about the final volume? That means the yield. Do we have a more yield in test tube X than in test tube Y? Obviously the amount of acid available to form this hydrogen gas is less than the amount of acid that is available in test tube Y. So however slow this reaction is going to be, it will essentially give us more yield because we will chip into the zinc a bit more with more number of moles of the acid available. So essentially it will be more. So the answer becomes B for 1.4. All right, so the answer is B. Okay, 1.5. Okay, so for 1.5, we are given the diagram below represents a mixture of nitrogen dioxide gas and dinitrogen tetroxide gas molecules at equilibrium in a 1 decimeter cubed container at temperature T degrees Celsius. All right, now the balanced equation for this reaction is as we know it. We've done this in the lab, in our school lab, so you must have enjoyed it. Okay, it's a brown gas, the nitrogen dioxide gas, and this one is light brown or colorless. So as we can see on our key here, we've got the number of molecules of nitrogen dioxide gas is 2, 4, 6, 8, 10, 12 against the dinitrogen tetroxide molecules, which is 2, 4, 6. Okay, It says, which one of the following is true for the value of the equilibrium constant, Kc, for the reaction at T degrees Celsius? Now, essentially, the number of molecules here, this is when we are at equilibrium. So that means that the concentration of dinitrogen tetroxide is going to be 6/1, which is basically 6 moles per decimeter cubed. The other one, which is nitrogen dioxide gas, is going to be 12 divided by 1, which is just 12 moles per decimeter cubed. So essentially, if you can see here, our product is dinitrogen tetroxide, and it is the one with the lesser number of moles at equilibrium. So that means that concentration is going to be less. So we've got a proper fraction where we've got a smaller numerator over a greater denominator. And this means our Kc value is definitely going to be less than 1, but it never is less than 0 anyway. So essentially, this one was a straightforward answer. The answer is D. Okay, because it cannot be equal to 1. It definitely is not greater than 1, and it is certainly not equal to 24. All right, so that is how that answer is looked at. So let's look at 1.6. 1.6 says a reaction is at equilibrium in a closed container according to the following balanced equation. So we've got copper oxide solid dissociating or decomposing into copper 2 oxide solid plus the oxygen gas. Okay, now let's have a look at this one. The volume of the container is now increased while the temperature remains constant. A new equilibrium is reached. Okay, so what happened here? We essentially increased the volume. That means we decreased the pressure here. All right, so decreasing the pressure will favor the reaction with the greatest number of moles of gas particles. All right, so do we have any gas particles on the left? No. Do we have any gas particles on the right? Yes. So this means decreasing the pressure here will essentially favor the forward reaction, which is the production of 2 moles of copper oxide as well as oxygen gas. Now, which one of the following combinations is correct for the new equilibrium? Now, it says the concentration of oxygen decreases. Technically, no, it does not, because the concentrations at equilibrium remain the same, or they stay constant. So anything that says decrease is out, so that means A and D are out, but remains the same is correct, because that's the definition of equilibrium. The number of moles of oxygen, okay, remains the same. Well, we can argue about that one, because if we're saying the concentration remains the same, that simply means the number of moles remain the same. Is it not so? But I think looking at these options, this one says decreases, increases, increases. So it simply is comparing the new equilibrium and the previous equilibrium. Obviously, since we favored the forward reaction, this simply means the number of moles will have increased. To say increases is incorrect, but perhaps say increased from the previous equilibrium to this new one. So that means anything that says increases, maybe it's acceptable, but probably the better word to use would have been increased, because it only increased when it did, but at the time we find it at equilibrium, it does not increase. So this is a bit of a crazy question, not well designed essentially. Anyway, equilibrium constant, we know that for the same temperature we will always have the same Kc value. Only temperature can change that. So essentially what seems to tick the boxes is C, although I'm not happy with that increases. It's not true. It definitely increased, but it does not increase. All right, so again, the best answer is C. Sometimes it's probably a deliberate move to say increases to cause you pain, because at some point you don't always choose the correct answer, but you choose the best answer. All right, because sometimes it is the best answer compared to the rest. All right, let's have a look at the next question. 1.7 says nitric acid, which is HNO3 aqueous, and ethanoic acid or acetic acid, which is CH3COOH, also an aqueous solution, of equal volumes and concentrations are compared. Now consider the following statements regarding these solutions. It says they have different pH values. Definitely, because an ionic solution of nitric acid has more ions than an ionic solution of acetic acid. Why? Because this is a strong acid. It almost completely dissociates in water, meaning there's no reverse reaction. Everything goes into the hydrogen ions and the nitrate ions. But with this one, it partially dissociates. So that means a lesser concentration of oxonium ions or hydronium ions or hydrogen ions and the ethanoate ion. Okay. Now, that is true. Because of the lesser concentration of the hydrogen ions compared to the nitric acid, they will have different pH values. Although both pHs are less than 7, but for nitric acid it's going to be much less than the pH of acetic acid. Both have the same electrical conductivity. Because of differing amounts of ions that they produce when they dissociate in a solution, they will have different conductivities, so they don't have the same conductivity. Both solutions require the same number of moles potassium hydroxide in solution for complete neutralization. Now this one is a tricky question. My student, can you see, put a tick in here, and I'm glad it did, because sometimes it's easy to say, look, this is a strong acid. Essentially, it dissociates more completely. So that means to neutralize those hydrogen ions, you would need more than it would be the case here. Okay, that sounds catchy and that sounds true. But the most important part of this statement is that complete neutralization. Now think about it. Since this is more of an equilibrium situation, now imagine when you start neutralizing the little hydrogen ions that have been produced when this one dissociated. What happens? You're favoring the forward reaction according to Le Chatelier. So eventually more and more of this acid is going to go into solution up until it's totally lost. So in essence, it will eventually be lost, because as soon as we take out some of these ions by neutralizing a small amount, this one will go more into solution, and that is why eventually all of this will actually be neutralized at the end. Yes, it's a slow situation, it's a slow process, but it eventually gets there. So that answer is correct. So that means the two answers is A and 3. Sorry, it's 1 and 3. So which of the above statement or statements is or are true? Obviously, we can see the 1 and 3 are correct. So that's C. So my student nailed this one. But when he asked what was the answer, I kind of put him under pressure. I said, no, that's not true. So, but yeah, I knew he got it. He got it. Anyway, 1.8 says, the apparatus in the diagram below is used for the titration of hydrochloric acid, aqueous solution, and an aqueous solution of potassium hydroxide. As you can see, we are adding the acid onto a solution, supposedly that of potassium hydroxide. Great. It says now in a titration, the learner accidentally exceeds the end point. This is when essentially the indicator starts changing color. All right. So that means obviously the accident here can only be adding more acid than you would say is adding more base, right? Because who is being added to who? This one is being added to the base. So essentially more acid ended up being added. And what does that mean? It means the pH will be acidic, or the final pH. Now it says, which one of the following will be true for the titration mixture? Obviously, we'll have more hydrogen ions because we've added more acid than necessary compared to the hydroxide ions, okay? And the pH will be less than 7. So A effectively is the best answer. Let's not even beat about the bush when it comes to this one. Okay, let's do 1.9. So we're almost done, guys. So the following hypothetical standard reduction potentials relate to a galvanic cell. All right. So we can see here that some element X in ionic form 2 plus 2 electrons goes and forms this atom, which is a solid, and it has a positive reduction potential. And then we've got some ion Y plus taking one electron, giving us that Y atom, and essentially its reduction potential is negative. So looking at this, we know that most likely for this to be negative, this must be a stronger reducing agent. For that one to have a positive reduction potential, that should be a stronger oxidizing agent. All right, so we were told this is a galvanic cell, so most likely we must have a spontaneous reaction. So technically, this is definitely the oxidizing agent, and that one is the reducing agent. Consider the following statements for this galvanic cell. The EMF of the cell is 0.20 volts under standard conditions. Obviously, the E cell potential is the potential of the oxidizing agent minus that of the the reducing agent. Essentially, this is 0.10 minus 0.10, and that means these two will end up adding together to 0.20, so that's correct. The electrode Y is the anode, most likely because of its negative reduction potential. X is oxidized, not true, because if X is an oxidizing agent, it means it is reduced. So those two should be the correct ones. Which of the above statements is or are true for this galvanic cell? 1 only? No. 1 and 2? Yes. And the answer is B, essentially. Okay, let's end this trouble. Which one of the following half reactions below will be the main reaction at the anode during the electrolysis of concentrated? Can you see that one? Concentrated. What does concentrated mean? More solute than water, meaning water is little compared to the amount of solute that is dissolved in it. Okay, so it says which one of the following half reactions below will be the main reaction at the anode. We know that at the anode it's oxidation taking place. Okay, during electrolysis of concentrated copper chloride. Now, is it copper accepting 2 electrons to form copper? The answer is no, because this is the reduction reaction. So this is what takes place at the cathode. So no. Water taking 2 electrons and essentially being reduced to hydrogen gas and what is this? The hydroxide ion. The answer is no, because remember, water is not a stronger oxidizing agent than copper, and essentially this is what would take place at the cathode, not at the anode. So it's out. Now, water being oxidized to oxygen and 4 hydrogen ions plus 4 electrons being released, well, this is possible. We know for a fact that water is a stronger reducing agent than the chloride ions. But because this is concentrated, it means we have more chloride ions than water molecules available. So most likely the main reaction is going to be this one, because when we say main, is what is prevalent, is what is going to be noticeable. So essentially it's going to be the chloride ions being oxidized to chlorine gas and releasing 2 electrons. So the answer here becomes D. Obviously you would be confused and think water should be, because it's a stronger reducing agent, but the problem is the concentrated. So how many more molecules of water are available to do this? Eventually, when it gets finished, what happens? This becomes the issue. So essentially, because water is too busy trying to separate these chloride ions, so essentially the main reaction is going to be that one. So some tricky questions, but very nice ones. So I hope you guys enjoyed the video and essentially liked the answers. So these are the answers that we got. So for 1.1 it was D, 1.2 is D, 1.3 is A, 1.4 was B, 1.5 D, 1.6 C, 1.7 C, 1.8 A, 1.9 B, 1.10 is D. Obviously guys, if you have differing opinions, please comment and correct the dude if he is getting something wrong. Otherwise, this is an attempt to give you my opinion of this question. See you next time. Bye-bye.